you've talked about these three core capabilities that are required for distributed artificial superintelligence, just as these three things were required for humans to be able to horizontally share information and achieve things together. So, sharing intent, let's focus on that one first. We'll talk about sharing knowledge and sharing innovation next. But so, how is intent different from knowledge, for example? So, I guess the key thing is with intent, I'm guessing it's related to being able to figure out what some agent, whether that's a biological one or an artificial one, is planning on doing. And so that's kind of different from knowledge, where knowledge is kind of like a set of facts, maybe. And so, yeah, so intent is, yeah, it's really this intentionality, this ability to predict what an agent is trying to do.
Let's break it down. So let's take that example that I just talked about. So intent, all of us are individuals. As individuals, have intentionality around a task that we want to do. So let's say uh, prehistoric times, since we're talking about that, we wanted to capture that hill. Now that is a shared intent. While we capture that hill or the village on the hill, we are all subject matter experts. So some might be warriors, some might be medics, uh, there might be a king or a leader, there might be a treasurer. We only have so many coins left or so much grain left. So there are all of these subject matter experts with their own intents and their own optimization functions. The shared intent is, can we capture that village on the top of the hill within budget with the least amount of casualties in the shortest amount of time, as an example. So that is a shared intent, because even though all of us might have different individual optimization functions and intents, a shared intent allows us to solve a broad problem together, keeping the various individual intents under balance. And so, in the concrete example that I talked about earlier, these two agents, so one agent is there to configure the network and make the best network possible. Since it's coming from Outshift and Cisco, we might not really dig into the details of compliance and cost and time, because that's not what this agent is supposed to do. The job of this agent, this individual genius, is to be really, really good at building out a network with all of the devices that it has in hand that scales well, performs well, and so on. And then there's this other agent in this case that is looking at compliance, that is looking at security, but is also looking at budget and on time delivery. So the shared intent is, can you build out this new network, which is awesome, performant, scales well, carries all kinds of traffic, but is on time, is under budget, and is compliant and secure. So that is a shared intent. You might have to make trade offs on one side or the other to make that shared intent happen, because individually they cannot solve it because they lack that common goal. So it's a common goal. So that's shared intent. Coming to shared knowledge, because you picked that, and what's the difference there? The shared knowledge.
Well, let's quickly, something that I'd love to just dig into on shared intent there for one quick second is, it sounds like in the distributed artificial superintelligence framework that you've come up with, semantic protocols seem to be the kind of the practical implementation of that shared intent. So maybe we could kind of, maybe you could kind of tell us, maybe even in the context of the Outshift example. And I love that you're giving us that concrete example. It makes it so much easier to understand what we're talking about here. So yeah, so maybe in the example you could go into these semantic protocols so that we can understand how that particular solution allows sharing intent in agents. And if you happen to be able to get more on the capturing the town on the hill as part of the analogy to help us understand semantic protocols, I'm really enjoying that one.
Right. So if you think about this example, because that's more concrete, let's go there first. Uh, the Outshift agent, which is the network configuration agent, has been built on technologies that are specific to Outshift. So we've built an agent using the cloud technologies, the models that are available to us. It actually mostly aligns with what we see in terms of regulations and laws in the US, because that's what we are most familiar with. It looks at design patterns that are pretty broad because as Cisco and as Outshift, we've looked at network design across many, many, many customers. So that's our worldview, and that's Outshift agents' worldview. It's like saying you and I, you have an Android phone and I have an iPhone, and we can send a text to each other. So you can see a green bubble and a blue bubble. Barely you can send text to each other. But you're speaking Japanese and I'm speaking English. So what's in those texts, we have no idea around. So we can connect to each other, but we can't communicate. We can't collaborate. There is no shared intent. There's no communication of information. There's no semantic exchange of information. There's no meaning behind this connection. And so the agentic world today is full of connectivity, but devoid of meaning, is the way I look at this. And what we're trying to do as a first step to enable shared intent is to bring about meaningful communication. And so when these two agents, coming back to our concrete examples, when these two agents talk to each other between Outshift and Swisscom, not only can they sit behind two models, two cloud technologies, and connect to each other and exchange messages through a protocol like A2A or MCP or whatever, but then talk about the layer above this and actually think about the meaning, start communicating semantic meaning, messages that actually convey meaning. And why is that important? Why that's important is we actually want to start looking at a common understanding. So when we talk about shared intent, the first thing to get to is grounding and a common understanding. What is the problem that we want to solve? And do we all agree on the same terminology, the problem space, the same objectives, the same goals? So that's step one. Step two is discovery. So maybe while we start looking at the objectives, we realize there's missing information. So can we start looking at and thinking about pieces of information and knowledge that are missing? Resolution of conflicting information. So we might say, I might say X, you might say Y, but there's now a common goal. Can we now resolve those conflicting pieces of information so that we are going after a common goal? Coordination, that's the big thing. Because again, I might have to give up some things, you might have to give up some things to actually achieve that common goal. So, coordination and then negotiations that come with it. And then finally, evaluation of those goals. So, all of these things can only happen at the semantic layer. It does not happen to just message passing and the protocols at that layer. So, the semantic layer that we're building out is actually a layer or a set of protocols that allow all of these things to happen, whether it's grounding, whether it's discovery, whether it's resolution, coordination, negotiation, and evaluation. And so those are the sets of things that we want to do to then enable shared intent to happen.